Hello everyone, it's Mr. Salimata over here. Today we're going to be looking at a second theorem problem involving reflex angle, an angle at the center, and cyclic quadrilateral. Okay, so let's get to the question over here. So the question reads, in the diagram, P, Q, R, and S are points on the circle with O and reflex angle PQR. Yes, reflex angle PQR, 220. Yes. Find the angle marked X. Yes, so our goal here is to find this angle right here, this angle X over here. Yes, okay, so if we look at our center here, we are given a what? A reflex angle, yes, which is 220. Yeah, and we know that it's a reflex angle because it's what? It's greater than 180. Yeah, okay, so our first step, yes, our first step would be finding the smaller angle here at what? At the center. Yes, and we're going to do that by using one angle fact. Yes, okay, so let's do this. Okay, yeah, okay, so angles, yes, angles around a point, yes, angles around a point add up to what? 360. Yes, so in order for us to find our angle here, our smaller angle here at the center, all we have to do is subtract 360, yes, 360 minus what? Minus 220, yes? So we subtract 220 from 360, okay? So let's do that, yeah? So we have 360 minus 220, yeah? And what does that give us? That gives us what? 140. Yeah. Okay. So we have now found our smaller angle at the center. Yes. So allow me to just write it over here. 140. Yeah. Okay. So our second step. Yes. Our second step would be finding what? Finding angle Q over there. Yes. And we're going to use a second theorem. Yes. So angle, yes, the angle at the center is what? Is twice the angle at the circumference, yes, standing on the same arc. Yeah, okay, so for us to find angle Q over there, yes, for us to find angle Q, we have to what? We have to divide our smaller angle at the center here by 2, yes, because our smaller angle here, yes, is standing on the arc PR, and our angle Q over there at the circumference is also standing on the same arc PR. Yes, are we together over there? Yeah, okay, so let's find our angle Q. So angle Q, yes, equal to 140 divided by 2, right? So angle Q equal to 2 into 140, that gives us what? That gives us 70. Okay, so now that we have found our angle Q over there, yes, 70, write it right here, yes, found our angle Q, 70, yes, we now have to look at what's happening around the circumference. Yes, if we look at point P, Q, R, and S, yes, they all lie on the circumference, right? So P, Q, R, and S is what? Is a cyclic quadrilateral, yes? And we do know that using the second theorem, opposite angles in a cyclic quadrilateral add up to 180, yeah? Okay, so we can now find our angle X over here, yes, because angle Q is opposite to angle X, yes? So how are we going to do that? All we have to do is we have to add angle Q, yes, angle Q plus angle X equal to 180, yeah? Yes? Okay, and we know the value of angle Q is what? Is 70. Yes? Plus angle X equal to 180. Yeah, okay. And what we have to do now is we have to isolate our angle X, right? And we can do that by simply subtracting 70 on our left side of the equation and also doing the same on the right side of our equation. Yes, we're subtracting 70, yes? And positive 70, negative 70, those two what? Cancel out, yes? And that leaves us with what? With angle X equal to 180 minus 70, that's what? That's 110 degrees over there, yes? So there we go. We have found our angle X, yeah? Okay, thank you so much.